In the previous lesson, we explored why protein and fat are such foundational biological inputs. Now we're going to talk about one of the most debated and often misunderstood categories of nutrition, carbohydrates. And the purpose of this lesson is not to make carbohydrates good or bad. It's to teach a much more useful clinical question. What can this body currently tolerate and process well? Because when it comes to carbohydrate strategy, the issue is often not just the food itself, it's the relationship between the food, the digestive system, the metabolic system, and the condition of the terrain. One of the most important things coaches need to understand is this: not all carbohydrates affect the body the same way. Carbohydrates differ in structure, digestibility, fermentation potential, glycemic effect, preparation, and overall burden to the system. And because of that, two people can eat the same food and have very different responses. One person may tolerate it beautifully, another may experience bloating, fatigue, cravings, blood sugar swings, immune reactivity, or post-meal symptoms. That doesn't necessarily mean the food is bad. It means the body's relationship to that food may be compromised. And that is a much more clinically useful frame. One of the important things to understand from traditional food cultures is this: many healthy traditional people did include carbohydrates. They often consumed foods such as roots and tubers, fruits, honey, smoked or soured grains, traditionally prepared legumes, and other whole food starches, depending on geography and season. So, the point of this lesson is not to suggest that all carbohydrates are inherently problematic. The point is to understand this: carbohydrates are not just one thing, and the form that they come in matters greatly. Traditional cultures often ate carbohydrates in ways that were less processed, more seasonal, more intact, and more intelligently prepared. That is a very different physiological experience than modern refined carbohydrate intake. A monosaccharide is the simplest form of carbohydrate. It is a single sugar molecule. Examples include glucose, fructose, and galactose. These simpler carbohydrate structures require less digestive breakdown before they can be absorbed, and that matters because one of the most overlooked questions in nutrition is not just what is this food made of, but also how much digestive work does the body have to do in order to handle it well. That is where digestive burden becomes a very important concept. And by contrast, more complex carbohydrates, such as disaccharides and polysaccharides, require more breakdown, more enzymatic capacity, and more digestive coordination before they can be properly handled. And this is a very important distinction. One of the most important principles in therapeutic nutrition is this: complexity when it comes to the diet requires capacity. More complex carbohydrates often require more enzymatic breakdown, more brush border function, more digestive integrity, more microbial balance, and more overall resilience in the terrain. And when the gut is inflamed, the brush border is damaged, the microbiome is imbalanced, or the person is already highly reactive, tolerance often goes down. This is one of the reasons why so many people feel significantly worse on foods that are often considered healthy. Because the question is not just, is this food nutritious? The question is, does this body currently have the capacity to handle complexity well? And if it does not, that food may not be fully digested or absorbed properly, which means it is more likely to become substrate for excess fermentation and microbial overgrowth further on down the tract. And that is a very important distinction. This is where things become very clinically relevant. When more complex carbohydrates, especially disaccharides and polysaccharides, are not fully broken down and absorbed well, they can become a significant food source for the wrong terrain. That means they may help feed opportunistic bacteria, pathogenic overgrowth, excess fermentation patterns, gas production, bloating, endotoxin burden, and immune irritation. This is one of the reasons so many people feel worse with starches, grains, certain legumes, or even quote unquote healthy complex carbohydrates, not because those foods are universally harmful, but because in a dysregulated terrain, they can become too much substrate for the wrong ecosystem. That is a very important systems principle because when the terrain is already unstable, more fermentable complexity can sometimes amplify the problem we are trying to resolve. Another major traditional nutrition principle is this: preparation matters. A carbohydrate food is not just derived by what it is, but by how it is prepared. Traditional food systems often use methods such as soaking, souring, fermenting, long cooking, and pairing foods with fats. These methods can often reduce the burden, improve the digestibility, and can make certain foods more tolerable. This is one of the reasons traditional cultures could often include grains and legumes and starches more successfully than many modern people today, because they were not simply eating dry, industrialized convenience versions of these foods. They were often eating them in a transformed and more digestible form. This is a very important teaching for us coaches. This is where the monosaccharide approach can become useful. By emphasizing simple carbohydrate structures, we can often reduce the digestive burden, the enzymatic demand in the microbial substrate load. And that can make carbohydrate intake easier for the body to manage during a season of repair. Because if complexity requires capacity, then one of the smartest things that we can do in a compromised terrain is temporarily reduce the level of complexity the system is being asked to manage. This can be especially helpful in people with intestinal inflammation, microbial imbalance, fermentation issues, compromised digestive capacity, increased immune reactivity, or reduced tolerance to carbohydrate, starch, and sugar. In those situations, simpler carbohydrate structures can sometimes feel less provocative, less burdensome, and more manageable for the body. This does not mean monosaccharides are universally superior. It means that they can be strategically useful when the terrain is not yet robust enough for more complexity. This is the clinical lens. It is also important to understand that carbohydrate tolerance is not just a gut issue. It's also a metabolic issue because even if a carbohydrate is digested reasonably well, it still has to be handled well by the metabolic system. This means that blood sugar regulation matters, insulin signaling matters, appetite response matters, satiety matters, and fuel flexibility matters. And this is where more complex, starch heavy, and highly glycemic carbohydrate patterns can become especially problematic in a dysregulated physiological system. Because over time, frequent exposure to carbohydrates that drive repeated insulin demand can contribute to poor blood sugar regulation, more hunger and cravings, more fat storage signaling, reduced satiety, and increasing insulin and leptin resistance. And that matters because once insulin and leptin signaling becomes distorted, the body often becomes less metabolically flexible, less responsive to satiety, more prone to overeating, and more vulnerable to weight gain and metabolic fatigue. This is one of the reasons carbohydrate tolerance must be evaluated not only through digestion, but also through metabolic signaling integrity. That is a very important principle. This lesson is also a very important reminder that food should not be moralized. A food is not automatically healthy just because it is whole, plant-based, natural, or culturally praised. And a food is not automatically bad just because it is being strategically limited. What matters is the terrain. Can the body digest it? Can the body regulate around it? Can the body recover from it? Can the body use it without excessive burden? This is where systems-based nutrition becomes much more intelligent than generic nutrition advice because we are not choosing food based on ideology. We are choosing food based on readiness, tolerance, and physiology, and that is a much more mature way for us to coach. So the big takeaway from this lesson is the right carbohydrate strategy depends on the conditions of the body. Not all carbohydrates are equal, not all bodies tolerate them equally, and not all therapeutic nutrition plans should look the same. Sometimes properly prepared whole food carbohydrates can be well tolerated and deeply nourishing, and sometimes simpler carbohydrate structures are more appropriate for a season of repair. The key is not dogma, the key is matching the food to the conditions of the terrain. That is the deeper purpose of nutritional architecture. And that brings us to the end of Module 3. See you in the next module.